Hello. This looks like it's everyone that's going to be joining us today. I'm going to get started right now. So welcome to the first lesson of our elementary programming class. Uh, in case you were here when we were doing our last session back in the summer break, uh, this class is going to be repeating pretty much everything that we've covered last summer. So if you're new to this class, that's great. If you've been here before, this might be a bit repetitive for you, but thanks so much for coming along. So first, I'm going to do a quick rundown of this class. We're going to first get to know each other a bit. We're also going to get to know the idea of programming and how we can program. And finally, we're going to get to know Scratch as a programming platform and a programming language. And finally, once we've made ourselves familiar with Scratch, we're going to build a simple Scratch program. And this will be the first the first project we're doing in this class. And hopefully it will be fun. So first, we're going to be using the Zoom platform, the Zoom online meeting platform for all of our classes. So you should take some time to get used to this app. And in particular, uh, at the bottom left corner of your screen, there are going to be two buttons, one called Unmute and one called Start Video. So when you're not speaking, please make sure that you are muted, which means that the mute button looks like this. And also, please make sure that you turn your video on so we can see you. We can see each other by clicking on the Start Video button. Thank you, Landon. And at the center bottom of your screen, you're going to see about 5 buttons. You don't need to worry too much about some of these for the moment. The chat function is one we're going to be using a lot. So if you have a question or a comment or a concern, you can click on the chat button at the bottom of the screen, and that will give you a small window, and you can chat with everyone else in the meeting so that we can see your questions and concerns. So you can either type your questions or there will be time slots set aside for the meeting. There will be time slots in the class where I will give you time to ask those questions directly out loud. You can either type your questions in the chat or ask them in the question time. So now that we've covered the Zoom basics, I'm going to do a little self-introduction, and then we're going to get to know a bit about each other. So my name is Harry Gong. I might have met some of you before. Some of you might be new. I am 14 years old, a lot older than you are, and I studied grade 9 at St. George's School in Vancouver. So in this class, I'm going to be teaching you how to code, how to make some simple Scratch programs. And personally, I have a really a passion for programming and making things with code. What I like most about programming is the idea of turning something abstract, turning like an idea into something people can use. And there are so many things we can do with programming. We're going to see some of them later in this class. But no matter what you create, the act of programming is creating something meaningful that people can use. And in addition, the process of programming, while you're writing the code, you also experience a sense of joy and accomplishment. So, so basically, coding makes me very happy. It's one of my hobbies. And I hope that for all of you, while you're doing this course and once you've completed it, I hope that programming will also become one of your hobbies that you can take joy in creating something with code. So enough about myself. So I'm going to ask each of you a couple of questions. First, I'm going to get to know your name. And if you would like to share why you would like to learn programming, that will be great. So starting with Lyndon, I've met you before, I think in our last session, but can you introduce yourself to the other people here?
Hi, I'm Lyndon. I just went to grade 3.
Grade 3. And what is it about programming that you like about it? Why do you want to learn programming, Lyndon?
It's because I've been on Scratch and I want to create a video game or something.
Yeah. Many people use Scratch to create video games, and making a video game is something cool that it's both fun to make and fun to play with. So we're going to be exploring creating video games a lot later in this class. And Angie, are you here?
Oh yeah. So my name's Angie, and I want to learn programming because I guess it's just kind of cool and I'm interested. So yeah.
Yeah. Nice to hear from you. What about Mia? Mia, did I say your name right? Is it Maya? Are you here? All right, I'll skip her then. And before we start, do you have any questions about this course, about what to expect, about programming in general?
Are we going to learn the whole thing again?
Yeah, so actually in this session, there will only be 4 classes altogether. So it'll be like a mini version of our last course. But if you'd like, we can also do something something that builds on the concept that we learned last summer. So Lyndon, I know you've participated in our last session. Angie, did you participate in our class last summer?
I might have. I don't really remember though.
Okay. So we're going to be repeating some of the things we learned. We're going to be reviewing them. But we're also going to see some new things in this course. So let's get started. First of all, can everyone think of something that someone can program? For example, Zoom, the software that we're using right now, is an example. Angie?
You can program like games or websites.
Yes, video games and websites are great examples. And what about you, Lyndon? Can you think of an example?
You could create like animation.
Animations, yes. Good. So there are a lot of things you can program. And here's the thing about programs. Programs always live and run on devices. So devices can be many things. They can be laptops or computers. They can be cell phones, but they can also be things like children's toys. TV sets, and even cars. So basically, a program is a piece of code that runs on a device, and the device is anything such as a computer that can run a program. So next, we're going to look at how we can program, because the goal of this course is to teach you about programming. So basically, when you program something, the first thing you have to have is an idea. What am I going to do with this program? What do I want to create? And next, after we have this idea of what we're going to create, we're going to break it down into its pieces and see how we can start with code and end with our product. And once we have an idea of how we might structure our code, what parts our code might have, we're going to tell the computer about that code so that the computer can later run it. And after we've created the code and we've told the computer about it, then what we have is a program. And a programming language is how you tell the computer what to do. So there are many programming languages. There are many ways that you can tell a computer how to behave. And many of these programming languages are text-based. So you might have heard of languages like C++, Java, Python, and so on. For these languages, you type code into a computer, and the code is processed by the computer in a certain way that makes the program make sense to the computer. But there are other kinds of programming languages, and the one that we're going to use for this class, called Scratch, isn't text-based. Scratch is, in case you haven't seen it before, looks like this. So Scratch is made out of pieces of instructions called blocks. And the blocks fit together in such a way that makes sense. And after we have a collection of blocks, after we've made a script with these blocks, we can tell Scratch to run it. And Scratch runs this code by displaying it on a window called the stage. So basically, everything you do with Scratch shows up on that little canvas, on that little window. And we're going to learn how to use it in a couple of minutes. And we're going to see one thing that we can make with Scratch. So on the Scratch website, which is scratch.mit.edu, there will be many projects that other people made and uploaded to Scratch. Each of these projects is a little program that everyone on Scratch can access. And here's one of these programs that I found that I liked quite a bit. So this program is an example of a type of game on Scratch called a platformer. This is quite a common game in Scratch. So basically, the player controls a character on the screen using the keyboard, the mouse, and through perhaps through a touch screen. as you can see here, the program, the main part of the program is this part. This part is called the stage. And we have, and when this program is published, this is what the program will look like. When we're still and this will be where you are going to see all the action. So you're going to see two little buttons at the top of the stage, the green flag button and the stop button. So basically pressing the green flag button tells the program to start. And once the program starts, it can do all sorts of exciting things, like having these coins that move up and down, and having the player control the program. So in this game, the player uses the arrow keys, the up arrow, down arrow, left arrow, and right arrow to control how the character moves. And, oops, let's start again. Yeah. This program is an example of a game, which are also very common on Scratch. So each game, in each game, the player controls a character, and the player wants the character to do something. In platformer games, the goal of the player is to get to the next level of the game. And if you saw those coins that were here right before this, another objective of this game is to collect those coins. So there are many games on Scratch. Some of the games don't look like this at all, but this is one of the most well-made games that I've seen on Scratch. So I'm going to be sharing this with you today. So as you can see here, the games also have instructions on how you should play the game. So and there's a place at the end of every stage in a platformer where you will advance to the next level, like this. Yeah. So Lyndon, you might have been somewhat familiar with these types of games before. Angie, would you like to like I'll give a try of this game?
Do I just go on Scratch?
Yeah, you can ask for on Zoom. There's a feature called remote control, so you can control the game in front of everyone.
Oh, okay.
So
so
at the top of your screen there should be
here I requested it.
okay.
So
you can use the arrow keys to move around.
Oh, okay. Oh. Ah. Oh, okay.
And
yeah, it's a pretty good game.
Yeah, it is. And the animations are pretty smooth. It probably took someone a lot of coding to get here.
Oh.
Oops.
Yeah, it's really fun though, and like it's really smooth.
Yes, it is. Yeah. Okay.
Okay.
So
do I give up remote control?
Okay. So as you can see here, we have this game that someone published on Scratch. For published games on Scratch, you can actually see the code that they used to make it by clicking on a button at the top right corner of the screen called labeled See Inside. And once you click this button, you can see all the code that they used to make this project. It's a lot of code. We're going to be making a similar project later on in this class. It's not going to be as smooth as this one, but it's going to look pretty nice as well. So some more things about this game that you might have noticed. There is a score. It's pretty common for video games in general to have a score counter that keeps track of how well the player is doing. And there are obstacles to the game that make the game interesting. For example, this section of lava here, as well as these cliffs here and the spikes here. So that's enough with this little program. Now we're going to learn how to make our own Scratch programs. And today we're going to make one from scratch. So first of all, you need to have a Scratch account. So if we go to the Scratch website, scratch.mit.edu, we're going to see a main page that looks like this. And Angie, do you have a Scratch account?
I'm pretty sure I do. For a school project once.
So you can sign in with that Scratch account.
Yeah.
Basically, to click on the sign in button at the top right corner of the screen.
Okay, and then I just create an account, right?
Yeah, if you have an existing account, you can just type in your username and password. But
okay.
Yeah.
Okay, I created an account.
Okay, good. And are you signed in now?
Yeah.
Okay, good. So once you're on Scratch, to create a blank project, you click on the Create button at the top left corner of the screen. Yeah. To the right of the Scratch logo, there's the Create button. And once we click on it, it's going to give us something like what we saw here, but it doesn't have anything on it. And we see the stage here, which is where everything happens, although not much is happening right now. This large blank area in the middle is called the code section. This is where we put our code. And this section at the left side of the screen, this is called the palette. And this is where we find all the blocks, all the instructions for Scratch. So if you look at the very left side of the screen, you can see a few circles that are colored. So the first circle that's selected is labeled motion. This represents the motion category, which are basically all the blocks that affect how the character moves. And the character is right here on the stage. And next in the looks category, which is the purple circle, we have everything that has to do with how the sprite looks, how the character looks. In the sound category, These are sounds that the character can play. The events category has to do with events that scripts can use to automatically begin a certain section of code whenever an event happens. The control section is everything that has to do with how and in what order the blocks are executed, in what order the blocks are run. And these are pretty crucial to making any sort of program because they have to do with how the blocks are organized. And there are a few more categories. The light blue sensing category, for example, which contains all the blocks that have to do with sensing the sprite's surroundings, like whether the sprite is touching the mouse pointer and so on. The operators tab, which is math operations and some yes or no operations, some text operations, and so on. And a couple more tabs, a couple more sections that we're going to be seeing later on. So this might be pretty familiar to most of you. I'm just showing this again for review. So once we have a general idea of how the blocks are organized in the palette, we can start looking at how to use these blocks. So for example, if we go to the blue motion tab, we see a bunch of blocks like move 10 steps and so on. If we click on one of these blocks, it will get the sprite to do whatever the block says. So clicking on move 10 steps makes the block move 10 units to the right, turn 15 degrees, makes the sprite turn 15 degrees. There's one for turning clockwise and one for turning counterclockwise, and so on. But if we want to make a program, just clicking on the blocks to tell the sprite what to do isn't very useful. We want a program that can run by itself. And to do this, we have to drag the blocks into the code area to actually combine the blocks into code. So if we start with a move 10 steps block, we can drag this into the code area, and it will be here. If we click on this again, it'll cause the sprite to move again. So what's so special about dragging blocks into the code area is that we can make things happen automatically, and we can also make combinations of blocks that run together, so that we can actually make the program do something useful other than isolated instructions. So first, we have the move 10 steps blocks, but the block only gets run when we click on it. We want this block to run whenever the user presses the green flag, which means that the program has started. And right now, pressing the green flag does nothing. This is because we have to use one of the blocks in the Events tab that we just saw. In the Events tab, at the very top of the screen, there's a block that's labeled when green flag clicked. So this matches up with our use of the green flag button. So whenever the user presses the green flag button, this block will be run. We can drag this into our script area, into our code area. And now we have the WhenGreen clicked block. So clicking on this block to run it doesn't do anything because the block isn't connected to any other blocks. But if we connect the WhenGreen clicked block to the move 10 steps block, when we have this, this means that the move 10 steps block will be run whenever we run the WhenGreen click block. So we know that the WhenGreen click block is triggered whenever the user presses the green flag. So if we try doing this, this will cause the sprite to move 10 steps every time the user presses the green flag. So once we have a general idea of what we're doing with Scratch, we're going to have a look at what we're going to make for the rest of this class. So Lyndon, you might have seen this before. Basically, the cat moves across the stage, first to the right, then to the left. And it keeps doing this as soon as the green flag is pressed, as long as the user doesn't press the red stop button. So right now, for what we have so far, the cat only moves 10 steps each time the green flag button is pressed. But we want the cat to keep moving whenever we want the cat to start moving when the user presses the green flag, and we want the cat to keep moving. So how we do this is through block in the control tab. This is the orange circle at the left side of the screen. So in the control tab, we're going to find a few blocks that have a pretty odd shape. One of these blocks, the third one from the top, is the forever block. This tells the sprite to repeat a certain set of instructions forever. So clicking on this block itself does nothing because no instructions are attached to it. But if we move 10 steps blocks into the forever loop and we press the forever loop, that makes the sprite move continuously 10 steps to the right. Do it again. And we want this to happen whenever the green flag is pressed. So we snap the when green flag clicked button. We snap the block right on top of the forever block. So we have a script that looks like this. When the green flag is clicked, then repeat move 10 steps forever. And we have something like this. And when the blocks are being run, you're going to see a yellow outline around them. This means that the blocks are being executed by Scratch. And to stop everything that's being run, you simply press the stop button, and the script will stop being run. So what if we wanted the cat to move a bit slower? Well, if you are in the orange control tab, you're going to see at the very top of the palette, wait 1 second block. And if you press it, it doesn't do anything. It only waits 1 second. But you can drag it into the code area And what if we snap this below the move 10 steps block? Then the cat will first move 10 steps, then wait 1 second, then repeat. So as a result, the cat moves once every 1 second. And if we wanted to move a bit more quickly than that, we can actually click on the 1 and change it to something else. So we basically click on the number and type in another number, like 0.1. And now the cat is moving. And one thing you've noticed is that the cat, once the cat goes to the right of the stage, it's stuck there. It can't move anymore. So if we have another look at this project, we want the cat to turn back as soon as it hits the stage, as soon as it hits the corner of the stage. So there's a special block in the motion tab that's for this. If we click on the blue circle at the left side of the screen in the palette, and we scroll down, we're going to find a block that says if on edge bounce. It's near the end of the blue section. If we drag this into the script, into the code area, and if we snap this right after the move 10 steps block, it's going to tell us, right, to turn the other way as soon as it hits a corner. And we're going to see that the sprite is turning back every time it hits an edge, but whenever it hits an edge, it's also turning upside down. And we only want the sprite to flip left to right to show the direction it's going in. We don't want it to go upside down. So there's also a block in the motion tab for this. If we click on the blue motion circle again, and we navigate to the bottom of the section, we're going to find a block that says set rotation style left to right. And there's a drop down menu. There are 3 options: left to right, don't rotate, and all around. So currently the rotation style is set to all around, which means that it can point in any of the directions. But we want to set it to left to right so that it only turns left and right when it hits the edge. It doesn't flip over. So if we drag this block into the code area, we can snap this right after the WhenGreen clicked block, so that we set the rotation style to left to right every time the code begins. So we're going to have this, and it turns the right way. Make sure the direction is 90 degrees. Okay. So now we have all the code that makes the character move. But if we look closely, the sprite doesn't actually seem to be walking. It seems to be sliding around the stage. So if we think about it, when we walk, we move our legs, and in every part of the steps that we're taking, where our body is positioned in a different way. So uh, for this cat, there's actually uh, an animation built in that makes the cat look like it's walking. So to do this, we're going to um, do something called changing costumes. Basically, it makes the sprite look different every time it takes a step, and that way it'll make the cat look more like it's walking. So the costume code is located in the Looks tab, which is the purple circle at the left side of the screen in the Padlet. So 6 blocks down from the top, you're going to find a block called Next Costume. If we click on it, each time we click it, it's going to make the sprite look something different. And if we observe how the sprite is moving, we're going to see that there are 2 costumes for the sprite. There are 2 ways that the sprite can look. And whenever we run the next costume block, it's switching between these 2 ways. So we want this to happen whenever the cat takes a step. So to do this, we basically snap the next costume block right after the move 10 steps block in the forever loop, and it will make the sprite take a step like whenever it moves. So the last thing that we're going to do is to make sure that the sprite goes to the center of the stage and that it points in the right direction whenever the green flag is clicked, so whenever the program begins. In the Motion tab, there's this is the blue circle at the left side of the screen. There's a block called Go to X something Y something. It looks like this. So these are the X and Y coordinates on the stage of the position that the sprite should go to. And every position on the stage is identified by a pair of coordinates, which are basically numbers that represents the x value, which is how far the sprite is horizontally from the center, and the y value, which is how far the sprite is vertically from the center. And the center of the stage is at x0, y0. So we want the sprite to be here whenever we start the program. So we use the Go to X, Y block in the Motion tab to do this. And if it doesn't say x0, y0, then you can click on each of these 2 numbers and type 0. And of course, x0, y0 represents the center of the stage. So we can snap this block right after the WhenGreen click block to make sure the sprite goes to the center every time we start the program. And finally, we're going to make sure that the sprite points right whenever we start the program as well. So in sprite in Scratch, the direction of the character, the direction of the sprite is determined in degrees. So 0 degrees is pointing upwards, 90 degrees is pointing right, 180 degrees is pointing down, and minus 90 degrees is pointing left. So we wanted to point 90 degrees, which is right, every time we start the program. To do this, we go to the Motion tab again, we click on the blue circle again, and we find the block point and direction. This block tells the sprite to point in a particular direction. And if it doesn't say 90, click here and type 90. And then snap this block right after the go to X0, Y0 block to make sure that the sprite points right whenever we start the game, whenever we start the program. And that's pretty much it. So here's our finished program. We're going to do a little review of the blocks and the concepts that we learned in this class. So first, I'm going to open a blank project. So pretend we already have the move 10 steps block in our code, for example. What should we do to make the sprite run this block whenever the green flag is pressed? Anyone? Angie? Lyndon? Which block should we use? It's in the Events tab.
The one with the green flag.
Yes. So the one with the green flag, the one called when green flag clicked, runs every time the green flag is clicked. And by itself, it doesn't do anything. But once we connect blocks to it, it runs the blocks that are connected to it. And one feature of Scratch that you should notice, so the little dents and the little bumps on the blocks indicates the order in which blocks should be run. So when two blocks are connected, when the when the bump in one block is connected to the dent in another block, this means that the second block will run as soon as the first block is done running. So when we have these two blocks connected, the move 10 steps blocks runs whenever the when green flag clicked block runs. So we get something like this. And next question. Which block shall we use? So pretend we already have this. Which block should we use to make sure the sprite doesn't turn upside down when it rotates itself at the edge?
Set rotation style.
Yes. So this block allows us to set the rotation style of the sprite, whether we wanted it to turn in every direction or only flip left to right. If we set the rotation style to left to right, then it will only turn left or right. And finally, how do we make the character run a set of blocks repeatedly as soon as the green flag is pressed? How do we make it repeat a certain set
Use
of blocks?
forever.
Yes. So the forever loops, the forever loop makes the character run the set of blocks that are within its bump and its dent forever. So if we have a code, if we have a script that looks like this, what it does is as soon as the green flag is clicked, first this block, the when green flag clicked block gets run, and then after it gets run, it finds that there's a block connected under it, and it runs the block under it as well. And the next block is set rotation style left to right, which sets the sprite's rotation style. And after this block, it triggers the next one, which is this forever loop. And inside the forever loop, once the forever loop gets triggered, it triggers the first block in this section. And the first block triggers the second block, and the second block triggers the forever loop again. And it goes back to the first block, then to the second block, and so on and so forth. And it looks like this. Oh, and be aware that even though the rotation style is left to right, we can still get the sprite to go in any direction we want. It can go diagonally, for example. So the set rotation style block only controls how the sprite looks when it's being rotated. It doesn't control in what direction the sprite can go. So that's pretty much it for this project. Do you have any questions? All right, so at Scratch, as you may have briefly seen, there's an Explore page. Hold on. If you're on the home page, there will be certain projects, public projects that will show up on your home page. And you can also click on the Explore button at the top of the screen to open more public projects that you can have a look at. So the project that I showed you at the start of this class was somewhere here, this one. And whenever you browse these projects, you can have a look at the code in these projects. You can see how the creator of this project programmed it to make it work. And you can use these public projects as a starting point for your own projects. So in addition to the projects that we go through as a group in class, you can also explore these public projects available on Scratch if you want further material to work with. And this is pretty much all we have for this class. Next class, since many of you might have a bit of experience with Scratch already, we're going to try something a project that we didn't try before last class, that last session during the summer. So if you have any questions about what we did in this class, or if you want to review if you want to review this class afterwards in your free time, I'm going to paste the link to this project right here in the chat. So it's in the chat now. You can refer to this code and the project whenever you would like to. And that's it for this class. And also, you can also reach me by my email address if you have any questions after class. I'm going to type it in the chat as well. Yep, it's there. Thanks so much for coming. See you next week. Bye.